Hello all, welcome to the another lecture on collaborative filtering. So in this collaborative filtering video, we'll try to do with the matrix factorization approach. So what is matrix factorization approach? I have just covered a little bit brief in the first lecture of this week, and so more detail will be in this YouTube link. Just go there and watch that YouTube video, which in which he will explain I guess very briefly what is matrix factorization properly. So in this lecture, we'll try to understand how the gradient descent works in this, right? So let's say this part, how we can compute the loss, and then how we can do the gradient descent of that. We'll try to understand that. So what we have is we have two metrics, one is P and one is Q, right? And the number of let's say P is based on users, right? So how many users are there and into factor of that. So if we see, we have in our data we have 943 user and 1682 items in that, and let's say we can take factor of 20, right? So if I do that, so I'll have 943 cross 20 metric, and another would be 1682 cross 20 metric. Now if I multiply P into Q transpose, I'll get a metric of size 943 cross 1682, right? So this matrix I'll get, and if you remember that this matrix is very same, which has same dimension to the one which we created with pivot table, right? So this pivot table, we took index, user ID, and a column as item ID, and ratings as value. In the previous two videos, we have taken this pivot table for item based similarity scoring and user based similarity scoring, right? So this data frame, you can see that is also 943, right? So the original matrix, which is this pivot table, you get, we will call that as R, right? And the one which we got just now with multiplication, we'll call this as R hat, right? Which both have same same dimensions, right? Now what we'll do is, okay, so we have this P into Q transpose and all, right? So we'll have R hat and R will compute the error between them. So R minus R hat error and squaring of that, and this is a regularization parameter. Okay, so we'll see, first we'll try to implement without regularization, and then we'll just add this regulation parameter on that. So if we were able to implement this part, then this part is just easier, right? So okay, now we have to do update and all, right? So before we go there, I'll just explain how we will do that. So what we saw is we have two metrics, P of 943 into 20 and Q of 1682 into 20, and R hat is P into Q transpose, that would be of size 943 into 1682, which the dimension of R and R hat are same, right? So what we are doing, what we'll do is we will take some row of P and some row of Q, right? So let's say ith row and jth row of Q. Now if we multiply with P Q hat, sorry, P and Q transpose, if I multiply that, then what I'm doing is I'm taking one row and one row like this. So let's say P some row Pi, and I'm taking so this is a row, and I'm taking another column. Due to transpose, it will become a column, right? So this is the jth column of Q. So this is Q j column, right? And if I multiply this, I'll get some value, right? So this value, what I'm going to get, I'm calling that as R hat I j, you can call now. So this one value you will get. Now you are going to compare that with R, right? So let's say my R looks like this, which has several things, right? So this is, let's say, R11. I'm going to compare R11 with R same dimension, should be of same dimension, so R11 hat, right? So this two comparison I'll do, and then I'll call that as error, that is R11 minus R11 hat, right? And similarly same thing I'll do for the next one, next one, and all of them, right? So all of this I have to do it. Now how will I do that? That is, I'll just run the loop around it and I'll do that, right? Now when we'll do the gradient descent or back propagation, the gradient descent, we take error and whatever parameter, so p is a parameter here. Now we take derivation with respect to that, and we update this weight, right? So this p matrix which we just now initiated will randomly initialize this, okay, and after each iteration we'll update the values in it, right? So how will I update that? So I'll take derivation of this, right? So just remember that, let's say I have if I take a small example of it, uh, let's say I have a user which has uh, 3 users in this and 2 dimension, right? So 2 users and 3 dimensions, sorry, 3 users and 2 dimension each. So this is 1 dimension, another dimension, and similarly I have 4 movies. Let's say 4 movies are there, 1 2 3 and 4 movies. So this should be 4 crosses. So I am calling this as P and I'm calling this as Q. So this is just an example of what we have seen earlier. Just think like the P matrix of size 943 cross 20. I'm now making it as 3 cross 2, and similarly I'm making Q as 4 cross 2, just to explain it, right? Now what we have done is we will multiply this with this one and I'll get the first value in the R, right? So R hat will have dimension of 3 cross 4. So 1 2 3 and should be 4 columns, right? So 3 cross 4. Now this value I'll get from multiplication of this with the first one, then multiplying this second I'll get this, and so on, right? So at each one I have to multiply it. Now what I'll get in the first cell is, let's say I'm calling P11. So this is P11, P12, P21, P22, and similarly I'll have Q11, Q12, Q21. Oh, if it is very messy, then I'll. So let's say this is Q11, Q12, Q21, and Q22, right? So something like, and so on. So in the first this multiplication, what I'll have is P11 multiplied with Q11 plus I'll have P12 multiplied with Q12, right? Yes. So I'll have this. Now this is my R, just 1 I can call hat. Okay, R11 hat. Now what I need to do is I need to find the loss function of error, right? So R minus R hat, R11 minus R11 hat, and square of that is what my error as of now I'm calling. I'm ignoring the regularization part. Now if I want to take derivative with respect to, let's say, P11, right, then what I have to do is this part contains P11, right, not anywhere else. So like we used to do in any gradient descent algorithm, we take 2R11 minus 2R11 hat, and then R11 hat is P11 component, and if I do derivation of this, I'll get Q11, right, from this. That's how derivation is done. Then I'll do with respect to tau P12 also, right? If I do with respect to 1 2, then I'll get 2 same thing, R11 minus R11 hat and Q12, right? So what I'm getting is, so let's say my first row of P, right? First row of P is like this, P11 and P12. Now similarly I'll write the derivation of both. So tau E by P11 and tau E by P12, right? Both of them I'll write like this, and I'll subtract this and use some learning rate out of this, right? So that's how the linear, that's how the gradient descent works. That you want to update this, you take derivation of this with respect to P11 and you subtract from P11, right? So P11 will subtract from that, and Q derivation of P12 should be subtracted from that, and some learning rate I have to use. So generally 0.1, 0.2, something like this, how I'll work. And similarly you have to do with the Q11 and Q12 also. So this is another thing, and learning rate, and you will get another matrix with Q11 and Q12, right? So these two things will get. So in so at once what you will do, so in one loop or in one iteration of the epoch, so let's say for epoch in range of, let's say some number you have to choose first, let's say 10. So epoch is all the elements should go through this, right? Something like that. Now in that, for each of the number in the array, I have to do this, right? So for each r value you can take as of now, just this is not a exact code, this is kind of pseudo code I'm writing. For each r value you have to run this, so there will be two loops inside, one loop on the inside another, right? So this is how you'll have. Now we will compute r hat 1 1, right? So what we'll do is we will first take out the p row, some I row, p I row, and q j row, right? So q j row will take, and then transpose of that I'm taking here, right? So transpose of that, and I'm going to multiply that, and this will give me r11 hat or ij hat. Rij hat is the correct one. Now if I have rij hat, I'm calling error as r1 I rij, so this is true one, the true r minus r hat ij, I'll get that and I'll square that, so I'll do that. Now I have to do the uh, gradient descent or the uh, back propagation, so gradient descent update I have to do, so gd update I have to do. Now what we are actually doing is, it's not actually gradient descent, this is sgd update. So we'll do this, we'll do sgd update, so at um, one data point at a time, something like that, right? So sgd update will do. Now sgd update would be whatever my p is, so p will have two values, right? Minus learning rate time, this dow e by dow pi, right? So pi I am writing as of now, that row, and similarly I'll do with q also, learning rate time dow e by dow uh, error by dow q j, right? So this I'll do, and I'll get, so this is what I have to do for all the r values. So for each r value I have to do, right, each r value. So 943 cross 1682 times this internal loop will work, and let's say if I run for the outer loop or epoch of 10 times, then into 10, so that many time I have to do this all the calculation, and I have to update each parameter like that. Okay, so just remember that in each internal loop for each r value, I am going to update only one row of the p and q matrix, right? So this p matrix and this q matrix, so one row or some I row and some j row is going to get updated in each iteration. Okay, yeah, so this is what we have to implement in code now, so we'll see how we can do that. Okay, now let me go to the okay, so this is what we are going to do is we will do matrix factorization approach for collaborative filtering. So this I'm yeah, so now I don't need actually cosine similarity, I just need this import pandas pd. Now same data frame I am importing here, right? So this will produce this folder here. Now I'm going to read the item from that just for the name of the data frame. There is nothing useful in the algorithm for this data frame, item data frame. Now we'll have data is being imported. Now the one thing which we can do is see the item ID and user IDs starts from 1, right? So if you see tf or data user ID, dot min, right? So it starts from 1, and similarly same thing is there for the item id also. Item id. Now there is nothing issue with that, but what we can do is we can make user id and item id starts from 0, just because when loop starts it starts from 0. In Python everything like the first thing starts from 0, right? So if we do that, then it will become just easier for us to later on not having confusion which row I'm going and multiplication and all, right? So to avoid that, we will reduce one from both of them. Now if you run this, let's say, then you'll get 0 as the one, right? So now it is starting from 0. For that only this code is there. Now for matrix factorized setup, we should know how many users are there, how many items are there, or what we can do, you can run this code also, which will give you number of uniques in item id and number of uniques in data user id, depends on you. I've just written it here, and some latent factor you have to take. This is going to be hyperparameter, any number you can choose. I've chosen it as 20. Now what I'm going to do is I'm going to produce two metrics, right? So this is p and this is q. So p matrix is np dot random. So this is a normal is being used. So normal means it will initialize weights normal with so there is a normal function, right? In statistics you would have gone through it, but if you don't understand this, that just think like we have initiated with some number, random numbers, right? Now yeah, so p dot shape and q dot shape. Now I will show you p, let's say first row, that would be the 0, right? So 0th one is a first row in that, and let's say first value is this, right? So if we see the full p, that is how it looks like, p with 0.49 and then something like that. So 0 0 is how you can do, you can, if you want the next one, second one, and so on, right? So what we need to do is we need to get the first row, get the first of p, get the first of q, and then do the matrix multiplication. So that's what we have to do. So let's say if I get p of 0 and I want to multiply with q of 0, we can do that, and some value I'll get. Now this value I'll use, and the original matrix, right? So the one which is here, you can use this, or maybe you can create a pivot table as you wish. You can, if you wanted to create a pivot table like this, that is also okay. But what we are actually doing is for 0th or what we'll do is we'll have 0th user and 0th item, right? For that we are doing. Now same thing I can extract from data also. So let's say data, and I need item id equal to 0. So if I do that, then true, false, something like that I'll get it. So if I run this, then this is for item id 0, right? All of them. Now I want user id also 0, right? Or this I can say user id is equal to 0. Now in this I need for item id 0, right? So what I'll do is I'll create another box. I'll write item id, and I'll call not like this, it should be outside of this, is equal to 0, right? So this one row I got from 0 0, and he has given rating of 5, right? So this is my the 5 number I'm getting here is of the true r or r, right? And the value which we have computed using this matrix multiplication is called r hat. So this is r hat and this is r. Now I have to compare both. So error, I'll get some error, then I'll do back propagation and all, right? So for this I have done. Now similarly I have to do for the p. Now this is the first element of r, right? So now 0 1 0 0, this 0 0 r 0 0. Now I'll do for r 0 1 r 0 2 r 0 3 and 4, right? So that many multiplication I have to do. So how will I do all of them is I'll write a loop and all, right? Okay, so so we have created this um, met, r hat, right? So we know how to find the r hat. Now we have to compare that with the r. So r I'll get from this uh, from uh, from the first, right? So this r is true, r is 5, and I have to compare that with the r hat, and I have to find the error, and I have to do that, right? So I have to do that for every element in this r hat matrix, right? But what we can do is we can escape that, or we should not do for all the elements of r hat. So r hat has this many, r hat will also have this many elements, right? 943 cross 1682, that r hat will also have that. That is, this is r hat matrix only, right? Now what we can escape is we can skip the part where the rating is 0, or rating 0 means the rating was not done, right? Why should we consider those values for the error calculation and and doing the gradient reset? Why should we do that? We should not do that, right? So to not do that, what we'll do is we'll only do for the rows available to us, right? So what we'll do is we have, let's say, so let's say I have this um, some row index, right? So that row index I'll use, and for row index I will figure out what is this, right? So for this row index, if I run for all the data shape dot 0, the range of data shape dot 0, if I show you that what is data shape of 0 is, that is going to be 100,000, right? So 100,000 times we have to we will do the updates of the weights. Otherwise what needs to be done is, otherwise what would be the issue is, let's say if we do for all of them, then so first in first iteration, right, what we do is we multiply one element, right? So let's say p of 0, and if I show the shape of that, p should be capital, right? So that is 20. So and similarly q0, if that shape is also 20, right? So this all the 20 or 20 plus 20 40 elements we have to update in each cycle. So if I update for all the r or the elements in r, that would be this many, right? So I have to multiply this also. So that will be a huge number, like that would be, let's say, 40 of this 20 plus 20 into 1943 into 1682, right? So this many updates would be there, which is around 63 millions, right, and more than that. But what we are doing is we will update for 100,000 only, and we'll be able to achieve that, right? So the idea is we should not update for the ones for which rating is not given to us, right? So for that we have written this loop, and not as every element of the r hat matrix, right? So this loop will provide one user, one id, and for this one part will update. So wherever it's not there, right, that element will automatically will not be there in the data dot shape, right? So data dot shape have no details about where rating was not given. So this is only data where rating is given. That's why this data exists, right? So each if you create this pivot table, you can see that here rating was not given. Somewhere nan values will come if we don't do fill value equal to 0. So that means rating was not given. So that data was actually not given. Data was not what we have in data table is what is given to us, right? That is the only thing we have to use. So we'll use this loop. Now what we'll do is we will, let's say, learning rate we can keep 0.01 for 20 epochs, or some epochs we have to run. Now we have to loop that, and this part we have just seen what it can do. It will give you each p, q, and r, right? So in each row, so we'll go row wise. This iter tuple will, so earlier we did with data dot shape. That is also okay, you can do that way. or another way is you can do iter tuple you write, and it will become a map, and then each row you can extract, and from that row you can get the column name you would write. So user rating, rating, user id, item id, something like that. So we'll use this approach. It's the same as that one. Now we'll do the prediction. So prediction was same as that. So whatever the row we got, in that row, whatever user index is, we'll use that in the p matrix, which was of user, and q is of item, right? So in that also we'll get the row. We'll do dot product. So this dot product is same as matrix multiplication, and we'll do the error calculation. And what we can do is, so total loss is error square, right? We can do that. And the derivation of error square is 2 times something like that. You can keep 2 here, that is also okay. If you don't keep, that is also okay. So we don't actually much care in gradient descent about the magnitude of the output, but what we care is we care about the direction in which it should do, right? So that's why we have learning rate also. Even though if this value is big, we have to set a very small learning rate. Let's say if it is 2 times, then I have to set even smaller learning rate, right? So multiplying with 2 doesn't make much difference. Even it is not good for the process which we are doing, right? So we'll ignore that. I'm just ignoring the regularization part, but if you do the regularization and add regularization parameter, then the derivation will become something like this. So this is a regularization, I haven't set, but you can set some regularization alpha, right? So this is alpha you can take, or this is what I call drag, and some value you have to choose. Okay, so if you do regularization, then you have to do that, and you have to add regularization elements also add to the total loss. But as of now we are not doing that, so you can ignore that, and I will ignore this also. Okay, and we will run it for 20 epochs. So that is all there, and then we'll print for each epoch how much total loss is there. And if I run this, then you can see the loss is first this, then second iteration it reduced, then reduce a little bit more, and so on, right? So it will reduce to some amount. So okay, so it has reduced to some good amount. Now the p matrix and q matrix would have updated. So these values are different than what we have initiated, right? So initiation would have given you a different kind of matrix. Now the matrix got updated, and this matrix is aligned with in such a way that we now get a good score, right? So we can do the rating and all. We can do the prediction of this. So let's say for we did for 0 0, right? Here we got the score of 0 0 as minus something, right? Now and the true value is 5. Now let's do for the now we have updated r hat, right? So the last prediction we will do that. So let's say if I do that, now it is 4.96, right? Very close to 5. So 5 is the true r, and this is the r hat. So we have done it for 20 epoch, and it has updated to a good amount. Now similar way we have to do the prediction for the unwatched movie, right? So a user has not watched any movie, I have to do the prediction for that. So for example, user target 4, so some target user is as a person, we have to define who is the user. We randomly take this, so we have to do for all the users. Okay, it's just I'm taking one user because at a time we can see for one user only, but a streaming website have many users, and they have to do for all the users. Now now for this user I'll take 4. So just remember that we have subtracted 1 from every user id and item id, right? So if you do the calculation, you should know that this is for user 5, user id 5. Okay, in the original matrix, user id 5 was this guy. Now similarly I'll do I'll find that so if I p, and if I want the 4th one, like I got 0th one here, I can get that. And this matrix, this is a vector, I have to multiply with that q transpose, right? So this q transpose is all the items right? I can do the multiplication and I get all the user ratings. So this is the prediction of all the user rating might give. So this user might give what kind of rating to each movie. I'll get that. Target user is not defined, so I think I've run this. Okay, now so this is what I got. Now you can see this, the shape of this should be as equal to number of movies, right? So 1682. Now the movie he has already watched, why should I recommend that, right? So that is the idea, and we have to find rated movie, unrated movie, and same thing, whatever the values are coming here for unrated movie, that will be the prediction. That is the only idea now there. So let's say rated items for data user id 4, or you can set to target user also, target user variable like this we have set, so that later on if you change it to something else, you can do that. So if I do that, and for that item id, I'm getting all the movies which he has rated, right? So these are the movie he has rated, and we have to get the items which he has not rated. So from 0 to 1681, I guess that is the item IDs will be there in the data. So if I see data item ID dot min, so that is 0, and let's say if I do max, that should be 1681, right? So this all values are there. I just have to exclude this from all the list, right? So all the list I have to exclude that, and let's say I want to find how much he would have rated any movie. So for example, 2 movies not there in the rated item, right? So let's say I wanted to find what kind of rating he might give. So what I have to do, I have to take this user ratings where we know, and it starts from 0. I'll just say that give me for the movie 2, right? So just remember this is not item ID, I mean the original one, we have subtracted from 1 from that, right? So it works that's only. He would have rated 2.54. That's how I can get it. Now I have created a list of lists. So what we are doing is we are saying that Q and user rating Q. So user rating Q is like this. So whatever Q is there, for Q in range, so range of number of items, right? So number of items will come from if Q not in rated item. So so if Q is not in rated item, then only we will consider that as a number items in this range, and for that only we will compute this Q and user rating of that, right? So if you can see, we have done that. So let me show you the top part. So you can see 2, 3, 1 was not included because it is already rated, and similarly 2, 3, 4, 7 something, and you can see if I show 16 should not be there, right? So like 16 is also not. So you will get all the unwatched movies rating now, rating predictions using that. Now what we'll do is we'll just have to show some movies, right? So let's say some movies are this. So 181 he would rate this much, 651 he would rate this much, and all, right? So you're seeing that some kind of the issue is that it is going beyond 5, right? It's going higher than 5. He would rate higher than 5, but the one thing we can do is we can either do clipping of it. I mean, if it reaches max of 5, then, or if it is more than 5, then make it 5. So these are just the prediction, right? We can't control how much it should be there. There is no such way in our objective function or algorithm that will control what should be the maximum value of the multiplication, right? So there is no such way, but we can implement that if it goes more than 5, then make it 5, and that would be the rating of that, and that's how it will work. So just one part you have to add more on this, that if max is that, then that would be the prediction, right? But we can consider this as a prediction, so that means he might like this movie a lot more than let's say 651 and all. Okay, so that's all is there. This is on the matrix factorization. You have to do that. So I'll just summarize it, what we have done is we took the data, then in this the data head part um, of the data set will be useful. So this u dot data will be useful, and in this each row represent one user id and item id and what rating he gave to that item, right? So this user 196 gave 242 some rating. Now for this row I'll find in P what row is there, in Q what row is there, and what is the multiplication of that. I'll call that R hat, and I'll compare that with rating, and I'll call that as error. So subtraction of that is error. I'll take squared error of that, and on squared error I'll, for gradient descent I have to do the derivation of that, right? So if I do the differentiation of that, so the differentiation will give me the this gradients. These are called gradients, and this gradient will update my original metrics which I've done, and that will lead to some good accuracy. So you can see mean squared error is reducing to some extent. Now it is 0.50, and I can make predictions out of this. Okay, so here we have used mean squared error um, as a way to evaluate the model, right? So earlier models, you can see we not evaluating it, we can just recommend it. There is nothing changes there, there is no weights or there is no learning happening there, but here there is some amount of learning happening, and that's why we need some objective function and parameters to control that learning, right? Yeah, so that's all there. Thank you.